Hello students, hope you all are doing well. So today we are going to discuss Newton's law of motion. Okay, let's start. So outline of this class is what? First we will discuss introduction of Newton's law. Second we will discuss prerequisite of this learning. What's the prerequisite required to understand this lecture? Next we will discuss Newton's first law. Then we will discuss momentum, then second law, third law, application, and some problem solving technique, right? So let's start. Actually, these 2 points, problem solving technique, application, and third law, we will discuss in next slide. In this lecture, we will discuss till Newton's second law. Okay, let's start with introduction of Newton's law. So first of all, who gave this? Sir Isaac Newton, a very great scientist or physicist, we can say, and Sir Isaac Newton gave this all law. Okay, and Sir Isaac Newton, also known as father of physics, he started the systematic study of physics in proper way, and he gave the lots of principle in physics like Newton's law of motion. Also, he works on optics, mechanics, and all. Okay, so next he gave this all theory in basic principia of mathematics. Okay, next these all Newton's law are the fundamental law of physics. Okay, and if we want to understand all phenomena of our daily life, this understanding of Newton's law is very important. But one more key point is what? This Newton's law holds true if the speed of object is less than c. Means this all actually not only Newton's law, classic mechanics, whatever we are going to discuss and nowadays we are studying, this all holds true if speed of the object is less than speed of light. When speed of object become very high, and imaginary case assume when it is very close to speed of light, in that case these all laws of motion and Newtonian physics will not work, right? So yeah, next move. Prerequisite of this class is what? First of all, we have to understand equation of motion. Equation of motion is what? First equation of motion is v is equal to u plus at, where v is final velocity, u is initial velocity, a is acceleration, t is time. Second equation of motion is what? S is equal to ut plus half at square. And third equation of motion is what? V square equal to u square plus twice a s. Right. So these all are the three equation of motion, and we have to also know how we can use these equations of motion to solve the problems. If we will get the command over this equation of motion, then only we can solve a question related to laws of motion, right? So this is very important. Next prerequisite is what? The basics of force. Okay, before going to next slide, here these all equations of motion that we have written, these all are true for constant acceleration, right? If acceleration will vary, these all equations of motion will not work. Okay, next we have to understand basics of force. I hope in previous grade you people studied force is what? Force is push or pull that can change this velocity of object, that can change the direction of object, that can slow the object, that can change shape and size of object, that can also slow the object, and if object is in rate it can initiate the motion, if object is moving it can stop the motion. So this is the basic of force. And if we are now discussing about force, the three thing is very important of force. Okay, the first is magnitude of force, second direction of force, and third point is point of action. Point of action is also very important for force. Okay, without this you cannot understand how the force will behave and how the object will behave under the application of force. Point of action, how important, just you can understand by one example. Okay, so see here, if suppose there is a big object, okay, if you will apply force at the bottom F, might be this object will start moving, right? And acceleration A will produce and this object will start moving. But there is also a possibility at place of this point, if you'll apply force at this point at the top, at place of moving, this object will start bending like this. Understood? So why bending and all that we will understand better in rotational motion. So as of now, just we have to consider, yes, in case of force, point of action is also important. Okay, so I hope you got this basic of force. Next we have to understand balanced force, unbalanced force and net force. So see, balanced force is what? When the net resultant of multiple force is 0. Suppose two force of 2 Newton, 20 Newton and 20 Newton is in opposite direction. So here net force is how much? 0, because force is a vector quantity. If this is 20 Newton, this will be opposite direction, will be minus 20 Newton. So plus 20 minus 20, this will be how much? 0 Newton, right? So net force on this is 0. So whenever the net force on object is 0, it's called what? Balanced force. Right? Unbalanced force just opposite to balanced force. If one or multiple force acting on an object and its net resultant is not equal to 0, we can say it is what? Unbalanced force, right? It is unbalanced force. Then net force is what? Net force we can calculate with the help of vector sum. I hope you all are aware of the vector. Suppose if two force F1 and F2 working at theta angle with each other, okay, the net resultant will be, we can apply vector sum formula. F1 square plus F2 square plus 2F1 F2 cos theta. This will be the net resultant of these two force. Suppose resultant F net is making angle alpha with F1. So what will be the direction of F net? We can write tan alpha is equal to what? F2 sin theta divided by F1 plus F2 cos theta, right? I hope you are aware of this formula. If you don't know and if you want me to explain, please write down in comment box. I will explain proving of this formula in our next video. Clear? So this is the balanced force, unbalanced force and net force, right? Next, we have to understand external force. External force is what? Basically, before going to external force, we have to understand object and system. Basically, suppose this is a mouse. Okay, it's made up of a small particle, and the internal force between its molecule, that is, you can say particle. So internal force is called what? Internal force. It is made up of particle, and the force molecular force for this mouse is called internal force. But if I am applying force from outside of the mouse, this force is what? External force. Similarly, if we have box and there are multiple objects inside the box, if we keep pen, this cover, etc., So the force between these all object, pen, cap, etc. will be what? Internal force of this box. But if you press it and all, it will be external force, right? So if force is coming from outside on any system or object, it is external force, and if it is from inside, it is internal force. And understanding of external and internal force will be very important to understand Newton's first law as well as second law. So there, when we will discuss first law and second law, this term again will come, external force and internal force, right? So external force is what? It is basically coming from outside of object or system. Okay, so now one more thing, system you can choose according to your weight. Suppose if we have 3 4, suppose mass m1, mass m2, mass m3, like this. Okay, so now it's your wish which one you want to consider as a one system. Only mass 1 also you can consider one system, combination of mass 1 and 2 also you can consider as a one system. It depends on your choice and your ease of solving the question. So the application, how we can choose the system and all, we will discuss while solving numericals based on Newton's second law. As of now, you just have to understand this system you can choose according to your convenience. Okay. Next, Newton's first law. Okay. So basically, Newton's first law defined inertia, right? So inertia is a natural property of the object. Okay. So a statement of Newton's first law is what? An object at rest stays at rest. An object in motion stays in motion unless acted upon by net external force. Okay, so if object is in rest, it will be in rest forever. Object is in motion, we can write here motion in motion with constant velocity. Okay, so if object is in motion with constant velocity, it will always will be in motion with the same velocity. If it is in rest, it will be always in rest. Okay, till what time? Till the time we will not applying an external force on this system or object, right? So now why we use this term external force? First of all, this only why it is more behaving like this object, it is behaving like due to inertia. Okay, the inertia is a property that making the object to behave in this way. Clear? So now we have to understand what is external force and what is the role of it. So try to understand, only external force of the on the object can change state of object, right? If there is no external force, state of object will not change. Wow. Suppose there are lots of force within the mouse, right? Intermolecular force, lots of force is working within the mouse between their molecules, right? But still, is this mouse is moving, or is there we can observe any change in this state of this mouse? No. Why? Because that force between molecule of this mouse is internal force of this mouse. Okay, so that cannot produce any state change in this mouse. Okay, now there is a very good example. If you have seen this movie Pirates of Caribbean, the Jack Sparrow was moving a boat, right? And there is a big cloth was attached to the boat, and the principle is what? When the air is blowing and hitting this cloth of boat, this boat starts moving, right? So now consider a case in which outside wind got stopped. Okay, and now anyhow, if we attached a big fan on the boat, right, a very big fan on the boat, and we plugged the fan with a circuit and switched on the circuit, right? Now this fan will blow this cloth, right? Now this boat will be able to move. Think. No. A big no. Why? Because this fan is now what? Internal portion of the boat, or it's an internal object of the boat. And when it will blow air on this cloth, this force also by the air on this cloth of boat will be internal force of the system. Understood? And we know that internal force of the system cannot produce any state change. That's why this boat will not move if we'll add a fan on the boat. Understood? So I hope now you got the understanding of external force and why external force we needed to change the state of object. Clear? Now come back to this example. Okay, it's a very famous example. Here we can see the animation. Yes. If we'll move this cardboard quickly, right? If we'll move this cardboard, that is here, I'm going to underline so you can understand. If we'll move this cardboard quickly, this coin will fall down in this glass, right? Why? Because see, coin has some inertia. This card also has some inertia. But when we are moving this card quickly, this card going to accelerate, but due to inertia, this coin tried to be in same state and it's fell down in the glass. Understood? Because of inertia of this coin. Very good. Now tell me one thing. If we will move this cardboard slowly, very slowly, if we'll move this cardboard, this coin will fall down inside. Still coin has inertia, right? But why not it's going to fall down here inside? Can you think? Take a pause and think about it. Yes. Now see, when we are when we are moving slowly, this coin also will move with board, right? If we'll move this card slowly, coin will move. Why? Which force is moving this coin? Friction force, right? Static friction force. If you studied in previous grade, static friction force will move this coin, right? Because we are applying force on card only. Now friction force is moving this coin. Why? Because this card is trying to move in this direction, and due to inertia, coin try to be at same position, so relative motion will be opposite direction. So to stop this relative motion, friction will be in this direction and this coin will move with the board, right? And here force applied by you on the card can maintained by friction force, right? That's why this coin will move. But if we will move card quickly, in that case we will apply a huge force on this card, and that time friction will not able to maintain that much force. That's why coin will fall down on the glass. So here we got the two understanding. First, due to inertia, coin will fall down if we move quickly, and second case, if we move slowly, friction will move this coin with card. Understood? Okay, so the second understanding is also important, right? Now move to the next very famous example. If we are moving in bus, and if bus will start accelerating suddenly, we will feel a jerk in backward direction. Why? Because see, a car or bus, whenever we are standing on bus, our leg is in contact with bus, and when bus will start moving, our leg will start moving, but back portion of our front upper portion of our body still try to be in rest, or that's same position. That's why the leg will move little forward, but body will feel jerk in backward direction, right? But again, if suddenly car will move, then only person will feel jerk. If it will move slowly, then person will not feel jerk, right? Next, we have to discuss inertia of motion, right? Inertia of motion means if object is moving, so that object try to be in motion forever until unless we are not applying external force on it. And see the example of inertia of motion, the seat belt of car. Why we are using seat belt in car? So suppose car is moving with particular speed, suppose 60 km per hour, 70 km per hour, and suddenly something will come in front of car. You will apply brake. What will happen? Car will stop suddenly because of brake, but your body still try to be in motion, so you will move forward, right? And if there is nothing to stop you, might be you will strike with windshield and you will get injured. That's why we are using what? Seat belt, that will stop you when you will apply brake suddenly, right? So that's why seat belt is very important. Next, if you are moving in bus and if bus will apply brake suddenly, what will happen? Your leg is in direct contact with bus, so it will stop, but upper portion of your body still try to be in motion, so that's why you will feel jerk in forward direction, right? Leg will stop but upper body will be still in motion, so you will feel jerk in forward direction. Okay, that is the example of inertia of motion. Now take a pause and think little more about inertia of motion and try to find some more example. Might be one or two example more you can get, right? If you have any doubt, you can ask or write down in comment box. I will explain. Okay, next come to the inertia and mass relation. Okay, so inertia and mass relation is what? Inertia is proportional to mass. If mass is more, inertia will be more. If mass is less, inertia will be less. So if we'll compare a heavy truck and small car, which one is higher, have higher inertia? Truck have higher inertia, although the car have lower inertia, right? Why? Because inertia is proportional to mass. Mass of truck is more than car. That's why truck has higher inertia, car has lower inertia. Okay. So any doubt related to inertia, please write down in comment box. Next, we have to understand momentum. Momentum is what? Momentum is a new physical quantity. It's represented by letter P, and it is product of mass and velocity, right? Momentum is product of mass and velocity, and we are representing by letter P. Now see, what is it? It's a scalar times vector. So obviously scalar time vector will be vector, so momentum will be vector, and direction of momentum will be in direction of velocity. If we talk about SI unit, SI unit of momentum is kg meter per second, right? CGS unit gram centimeter per second. Now task for you is what? You have to convert SI unit of momentum into CGS unit of momentum. Okay, and write down your answer in comment box. Okay, and if you are facing difficulty in conversion, ask me, I'll create another video for it. Okay, so this is the momentum. Now change in momentum also we have to understand. So change in momentum is what? It's represented by delta P. So suppose mass of object is m, initial velocity is u, final velocity is v. So change in momentum is final momentum minus initial momentum. So we can write m v minus u. This will be the change in momentum. Change in momentum is also very important for Newton's second law. That's why we here discussed Newton's second change in momentum. Okay, so now we have to solve one numerical based on change of momentum. So given that a ball of mass 0.5 kg is moving a ball of mass 0.5 kg is moving towards a batsman with his speed how much? 40 meter per second, right? The batsman hits the ball in opposite direction, making the ball move with his speed 60 meter per second. Okay, in the opposite direction, right? We have to calculate change in momentum. So here what happened? A ball of mass 0.5 kg is moving, suppose in this direction, how much? With 40 meter per second, right? And it's a strike 2, suppose this is bat and moving in just opposite direction with a speed how much? 60 meter per second. And we have to find out change in momentum. So students, might be many of you will do what? Mass into 60 minus 40, and they will calculate change in momentum. Means 60 minus 40 is 20, and 0.5 kg means 1 by 2, that they will calculate 20 kg meter per second, and that is absolutely incorrect. Why? Because we just discussed momentum is what? It's a vector quantity, right? So direction also we have to keep in mind, right? So suppose this direction is positive, then this velocity will be what? Plus 40 meter per second, and opposite direction will be minus 60 meter per second, right? So now we can write change in momentum is mass into v minus u. So mass v is how much? Minus 60. U is how much? Plus 40. So minus of plus 40, right? And mass is given how much? 0.5 kg means 1 by 2 kg, and minus 60 minus 40 is how much? Minus 100. So it will be minus 50 kg meter per second. Minus is showing what? The direction of change in momentum is in this direction, and obviously we can see also finally object is moving in which direction? In this direction, right? So here change in momentum will be 50 kg meter per second, not 20 meter per second, right? So you have to keep in mind direction, especially while calculating change in momentum and when direction is going to change. Clear? Okay. Now we have to understand Newton's second law. The statement of Newton's second law is what? Rate of change of momentum of an object or system is directly proportional to applied unbalanced external force on object or system. Here object we also understood, with system we understood, external force, unbalanced force, everything we already learned. So directly here now we will derive the expression for force. So according to statement, suppose F is unbalanced external force on the system or object. So according to this statement, it is proportional to rate of change of momentum. So rate of change of momentum we can write what? dp by dt, right? So here we can write it is proportional to, and p is what? M into v. So if m is constant, we can write m dv by dt, right? So here we can write proportional to m into a. Now if we'll remove the proportionality constant, suppose a constant k come into the picture. Now for SI unit, or we selected the unit, you can say, of F, M and A in such a way that if we will draw the graph between F and MA, we will get a straight line, obviously because F is proportional to MA, and this slope will be equal to 1. It means force by MA is equal to 1. So value of K is how much? 1. So we can write F is equal to mass times acceleration, right? Okay. So now if we talk about the SI unit of force, unit of M is what? Kg. Unit of A is meter per second square. So SI unit will be kg meter per second square. This quantity also known as Newton. Understood? Next, we have to discuss CGS unit of force. So we already know F is equal to M into A. So if we talk about CGS unit of F, so F is equal to MA. So that is equal to what? CGS unit force for CGS unit of mass is gram, and A is centimeter per second square. So CG unit of force is gram centimeter per second square. This quantity known as dyne. Now we have to convert 1 Newton is equal to how much dyne, right? So 1 Newton is 1 kg into 1 meter by 1 second square. We can write, right? And dyne is what? Gram centimeter per second square. So 1 kg is equal to how much? 1000 gram. 1 meter is equal to how much? 100 centimeter. And obviously second is second. So directly we can write. If we'll multiply, we will get 10 to the power 5 gram centimeter by second square, and this quantity is known as what? Dyne. So we can write 1 Newton is equal to 10 to the power 5 dyne. Clear? So I hope you understood Newton's second law as well as SI unit and CGS unit of force, right? Now come back to the numerical, okay, based on Newton's second law. So here given that two masses m and small m connected to a weightless string and is pulled by the force F on a frictionless horizontal surface. What will be the tension in the string between the two masses, right? So suppose like this. And suppose another string is like this and small m. And this force is how much here? Someone applying force F, and this is frictionless. So if we talk about a small m, so it's on a small m, force will be in this direction, tension will be in this direction, right? And suppose acceleration of this object is a, so we can write F minus t is equal to small m into a, right? Now for capital M, we can write t is equal to if it is moving in this direction, so this capital M is moving because this string is what is not going to increase in length, so inextensible, so this also will move with a acceleration, and this acceleration will produce by which force? Tension force. So we can write t is equal to capital A into a, right? Now the t is equal to capital M into a. So from here we can write the expression for t is what? We can find out first expression for a, because a is also unknown. So by using first equation we can find out acceleration value. By both equation we can use acceleration value. So just because it is equation 1, it is equation 2, we can add. So we will get what? If we'll add tt, will get cancel out, we will get F is equal to a into capital M plus small m, right? So here we can get a is equal to F divided by capital M plus small m, right? Now this value we can put in this equation, right? So tension will be what? Capital M into a, that is F divided by capital M plus small m, right? So this will be the value of tension. Okay, so students, I hope you understood today's lecture. If you have any doubt, please ask me in comment box. I will try to clarify your all doubt in next video. Thank you.